This is part 3 of going over chapter 4 test. Chapter 4 test. Problem 5 we're on here. On this one, it says we've got a 5,000 square foot rectangular plot of land, and it's divided into 8 fenced areas as you see below. Okay, what are the dimensions for X and Y that will minimize the amount of fencing that I want to buy? Okay, so first of all, if we want to minimize fencing, we need an equation for fencing. Here it is. How much fences? Well, look at this. I've got 1, 2, 3, 4, 5 X's. So 5 X pieces plus, okay, then here we go. How many Y's? I got 1, 2, 3 Y pieces. So there it is. That's what I need to minimize. Well, yeah, but how do I do that? Well, I get the first derivative and set it equal to 0. But there's 2 different variables. Well, what do I know about X and Y? Here's what I know. I know that this area is 5,000. So I know on a little rectangle like this, I know that X times Y equals 5,000. I'm going to solve for one of them. Let's get the X by itself, okay? Here we go. Divide by Y, divide by Y. Okay, here it is. X equals 5,000 over Y. That right there, I'm plugging into my equation. Let's do it. Here it is. F equals, in place of the X, it's going to be 5,000 over Y plus 3Y. Looking good. We got only Y's in there. That's great. But I don't want the Y on the bottom. I'm going to rewrite that. Here we go. Hey, 5 times 5,000, that's 25,000. And wait, this is Y to the first down below. So that's Y to the negative 1 plus 3. Okay, there it is. It's ready now to take the derivative. Let's do it. I'm going to do the derivative right here. Here it is, F prime. I'm going to take the first derivative, set it equal to 0. Hey, derivative of 25,000, Y to the negative 1. Negative 25,000, Y to the negative 2. Plus the derivative of 3Y, just 3. Take the first derivative and set it equal to 0 and solve. Okay, how am I going to solve that? First thing I'm going to do is minus a 3. Minus a 3. Here's what I got. I got negative 25,000. Now wait a second. Y to the negative 2. You know what that means? That means Y squared in the denominator equals negative 3. How do I solve that? How about cross multiply? Okay, here we go. Let's do that. Cross multiply this way. I got negative 3Y squared. Cross multiply this way. Negative 25,000. Oh yeah, here we go. Divide by a negative 3. Divide by a negative 3. Y squared. Let's do that. 25,000. Okay, negative 25,000 divided by negative 3. There it is. Good. 8333. Okay. 8333.33. Take the square root, take this. Okay, here it is, our Y length. Okay, this is our Y length, the square root of 8333.33. Nice, 9128. Okay, 9128. There it is. Okay, let's kind of squeeze it down. That's the Y now. 9128. And what is this? This is in feet. How do we get the X? How do we get the X? Yeah, right over here. Look at this equation. 5,000 divided by your Y. 9128. Do that in your calculator, and you get about 5477. 5477. What were the units for X? Yeah, just feet. Now, Next question, last question. What's the total amount of fencing? Use this equation right there. Okay? 5 times the x, which is 5477. 5 of those pieces plus 3 of the y's. Each y was 9128. There we go. And you get a total of about 547.7. 547.7. Now this is just the length of fencing, so it's just feet. There it is. Hey, let's go to 6. Okay, we've got on this one, we got the airplane problem. Okay, we got an airplane is flying at an altitude of 5 miles and passes over a radar antenna as shown below. Great. It always flies at 5 miles, at 5 miles high. It doesn't go up or down any on that. It's just a level flight. Okay, first question. When the distance between the antenna and the plane is 17, what is the x value going to be? Well, here's what you got. For part A, here's what I see. I see a little triangle. Okay? This is always 5. This is the x. Here's the plane here. Show some speed. Okay, there's the plane. Now, this from the antenna to the plane is 17 miles. What's the x? Well, look at it. You got Pythagorean theorem. Here we go. Let's do that. We got 5 squared plus x squared equals 17 squared. We got 25 plus x squared equals 289. Okay. Minus 25 minus 25. X squared equals 264. Root. Here's our x. Our x equals 1625. Okay, so we know that. 1625 what? Okay, that's going to be miles. Okay, now, what is the equation that relates an x, the 5, and the z? Do not plug any numbers in. Okay, I want an x, a 5, and a z. What's the equation that relates those 3 things? It's right there. It's Pythagorean theorem. Okay, here it is. 5 squared plus x squared equals z squared. You don't plug any numbers in yet. Now, part C, the derivative of part B. So the derivative of 25 squared, 0. The derivative of x squared, well, here's what you got to ask yourself. Is the x changing in this problem? Absolutely, it's getting bigger. So if the x is changing, yeah, we're going to do the derivative of the outside. That's 2x times derivative of the inside. That's dx dt equals. Is the z changing? Yes, it is. It's getting bigger. As the plane goes to the right, the z distance from the antenna is getting bigger. So I not only have to do the derivative of the outside, which is 2z, derivative of the inside, dz dt. And that equation right there in part C, that equation is why they call it related rate problem. There's 2 rates and they're related. Okay. Now, let's see what we got. Part D. What is the speed of the plane when the distance between the antenna and the plane is 17? So when z equals 17 and the distance between the antenna and the plane is changing at 225, that is dz dt, because that's how fast the distance between the antenna and the plane is changing. That distance is called z. So it's changing at 225 miles per hour. Let's plug everything we know into our equation right there. Okay, here we go. I don't have to put the 0. 2 times x. What's the x value? Oh yeah, that's 1625. What's the dx dt? Oh, that's what I want to find. equals 2. What's the z? Oh yeah, there it is, 17. What's the dz dt? Oh yeah, that's 225. Okay, here we go. Multiply. I got 3250. Okay, dx dt equals, on this side I got 7650. Let's divide by 3250. Divide by 3250. dx dt, this is the speed of the plane. It's going to be 235 and a little extra. There it is. 235 and a little extra. What are my units? Well, look, x on top, that's in miles. T is on the bottom, that's time, that's hours. Oh yeah, there it is, miles per hour. Okay. Hey, that's part 3. We got one more problem. Hang in there for part 4.